Okay, guys, we'll kick off. We've got Kelly Shortridge doing Paint by Numbers, Resilience and Security. If you can just give her a warm welcome. And once again, reminder, you can do the questions online, and if we could hold all questions to the end. Thank you very much. Take it away.
Thank you for having me. This is actually my first time in Australia, and it's been wonderful so far. So today I'm talking to you about resilience and security, and the theme is paint by numbers, and I'll explain what I mean by that. First, I'm Kelly. I work at Security Scorecard as a product manager. It's a security startup in New York doing third-party risk management. In my spare time, I research the intersection of behavioral economics and Infosec, as well as a few other domains. So that's the bulk of my research. So this is some ways bringing more of my product management side today than the behavioral economics side, but really it involves both elements. I always like to start with a quote to really set the theme, and given it's paint by numbers, I thought Andy Warhol would be quite appropriate. They always say time changes things, but you actually have to change them yourself. I would say information security seems to understand that there need to be security metrics that we need to start measuring our programs, but it seems like we're expecting some sort of magical fairy to show up and gift us some neat little package, which isn't going to happen. We're going to have to change things for ourselves. So I'm hoping that this is a good starting point. So why are we waiting? I think there are a few things why we are. One, we're all reasonably intelligent. We tend to be more scientifically driven. We appreciate metrics. But I think the bulk of the problem is actually that we treat security as this kind of absolute abstract concept. In a recent keynote, I analogized it to some sort of religion, that there's this sense of security dogma, that there are these immutable principles that need to be followed no matter what, regardless of context. And I think this is why we haven't been able to develop metrics and why we're waiting. Because trying to find some sort of absolute measure of an abstract concept just isn't going to work. Just think about how can you actually measure something like love? I think it's very difficult. You can see some sort of outputs related to love, but trying to find some sort of absolute measure that applies to everyone just isn't feasible. Instead, a contextual measure of a definable outcome is reasonable. And I'll get into examples of this. What I mean is that you have to take into context your organization or yourself, and you have to be able to define the outcome. It can't be abstract, otherwise you'll never be able to achieve it. Fundamentally, if we keep treating security as this sort of religious crusade where we're trying to impose our security morals on the rest of the world, success is only by taking control. In historical examples of religious crusades, the way that they measured whether it was successful or not was obviously by taking back Holy Land, and ideally indoctrinating people as well. That obviously isn't going to work for security in the context of an organization. Everyone will hate you and you won't actually get anything done. But if security is treated as a product, success can be defined and measured. I've talked, again, in that keynote about security as a product. I have a very long blog post about it, so if you have 30 minutes to spare, I recommend reading that, because this talk won't go entirely in depth on security as a product, but the same principle applies. You have to be able to define and measure success. As a practical example, if your New Year's resolution is, let's say, be a better person, what does that mean? That's going to be different for everyone. It's very likely you aren't actually going to succeed because you don't know how to actually measure your progress towards that goal. What does it mean? However, if you say, okay, my goal is to read 30 minutes per day and then volunteer 1 time per month, that's something you can actually measure. That's something you can work towards and see how successful you're being. So very similar, I know quite a few product security people. As an example, if you just say, okay, let's make this product secure, what does that actually mean? You have to get very granular with your goals, otherwise you won't actually make any progress. So my view is it's actually time to paint your vision, what everybody wants, which is improved security. Don't just leave the canvas unfinished because you were waiting for this kind of, again, absolute measure for this abstract concept. Start by creating the little numbers. I think everyone's probably painted by numbers here. It's pretty helpful. I'm pretty bad at drawing, so I find it very useful. So you put those numbers, then you can actually start filling in your picture. The format of this talk will be first, why measurement actually matters, some examples of resilience in complex systems, resilience metrics in DevOps, because kind of my current theme is that DevOps and security should be BFFs, but they aren't talking to each other, which is kind of weird. And then finally, measuring InfoSec resilience. So first, why is measurement important? I'd say probably everyone here would agree, generally we do a thing in order to achieve a certain result. Very rarely do we do something without wanting to achieve something. So, as an example, you've come to this talk probably to learn something or to see pretty pictures that are very colorful. A process is a series of actions taken in order to achieve a particular end. So again, the process is those series of actions that lead towards that goal. The problem is you cannot people or technology your way out of bad processes. I would say security has very bad processes. We see a lot of articles about the security talent shortage, see a lot of stuff about how technological solutions are inadequate, they're too fragmented, whatever else, but we don't see a lot of attention paid to the fact that our processes don't really make sense. They aren't goal-driven. So what you need to do first, and why, again, measurement is important, you have to first define your desired result and what counts as success. Again, that read 30 minutes a day. And what I mean more specifically is not just, yay, now we're secure. It's getting more granular, like making sure X product has like secure connectivity, and more than that, like, is it using what version of TLS? Vision is also very important. Again, I talked about this more in security as a product, but an example vision is, for example, reduce the security team's workflow volatility. Any sort of vision is the overall theme or goal that you're trying to work towards. In this case, no one likes context switching. I think that's one thing that leads to burnout. No one likes having to scramble. I think we all know about firefighting. So you're not going to be able to meet your goals if you have a lot of volatility. Success, for example, could be, in 1 year, my security team will spend only 10 to 15% of time on firefighting. Some of you may be realizing right now that you aren't actually tracking how your time is being spent, and I'll get into that. But this supports the overall vision and also is a tangible metric that you can measure. Another example is, in 6 months, what I call just-in-time pre-GA security reviews. Oh yeah, we're releasing to customers tomorrow. Can you take a quick security check? Which never is actually quick. In theory, you could decrease those by more than 50%. That's another measure that supports that vision of reducing volatility. So integrating security earlier in the design lifecycle is something I'm going to talk about later as well, but is probably something that spans a bunch of different visions. So success metrics and measuring your success allows you to create the numbers by which you paint your vision, and also track your progress in painting your vision. To get into definitions, so there's absolutely no ambiguity, I view metrics as quantifiable measures to track and assess status. Metrics are not things that are just something you put on PowerPoint in order to show your executives that you're doing something. That's not valuable at all. It has to be something that's showing your progress towards a particular goal. And your process, again, measured by metrics, has to reflect a relentless pursuit of continuous improvement. I'm going to talk in a little bit also about there's no such thing as a mature security model. That just doesn't exist. But there's no such thing as a mature program. So you have to really be thinking about this continuous improvement, which dovetails into resilience specifically. I'm not going to dwell too much on this. I have a presentation called The Red Pill of Resilience that goes into a lot more depth. So if you want to learn a lot about natural disasters and climate change and resilience in other domains, I recommend looking at that. But I will touch on it briefly. So first, what are complex systems? The shortest way of putting it is there's nonlinear activity in the aggregate. Basically, there are a ton of underlying components that make it very difficult to actually plot out everything given the number of variables. So it makes it very difficult to predict behavior. Examples of complex systems obviously our universe, but also our cities, our brains, our bodies. It kind of is interwoven into the world around us. Infosec also happens to be a complex system. We have defenders, attackers, users, governments, vendors, service providers, a whole host of people. It consists of highly connected, dynamic relationships. And again, both sides of the equation are human, which is where the behavioral economics comes in, but it means that it's much harder to track anything linearly. So evolutionary resilience. So in ecology, there was kind of this evolution, no pun intended, of the way that they thought about resilience from think about the traditional engineering definition, which is, can you bounce back to where you were? That doesn't make sense for a lot of systems because it means that the prior system was inherently vulnerable. So you don't actually want that. You want to co-evolve with any sort of change. So what this does is it focuses complex systems and the goal of those to be able to adapt and transform. So it's not enough to be able to withstand some sort of external shock. You have to be able to adapt with it and then transform around whatever it is. Essentially, it rejects the idea of multiple thresholds, like, okay, we've moved from this paradigm to the next paradigm. It's about that continuous fluctuation and evolution along with whatever context is in your environment. The result of that is that they found there are kind of three central characteristics of resilience. Those are robustness, adaptability, and transformability. These components mean that resilience is really a journey. All of those things aren't static things in time. It is an ongoing state of being. So it's not a singular final destination. It's a sustainable process rather than a goal. That's a very key point. There's an ecological and economic scholar named Peter Timmerman. He viewed resilience as the building of buffering capacity into a system to improve its ability to continually cope going forward. So as an example, natural disaster resilience has to assume some sort of failure of controls. It's not like they can reach some state, okay, we've implemented controls, we're good, we're resilient forever. That's not true. As a pretty tangible example, in America, in Texas, there was Hurricane Harvey, which had like devastating damage. There were storm surge barriers, which were the control against any sort of tropical storm. However, the problem was not that the damage was caused by that, it was caused by flooding, which they didn't have any controls for. So you have to assume your controls will fail, and again, continue to evolve it. So now they're actually working on developments to help with the flooding problem. Another example, which could be a metric, is what percentage of human development is in known at-risk disaster areas. So for example, less than 3% of people living in the state of Illinois have flood insurance that are living in floodplains. This is because they have levees in place, which means it's not at risk. Technically speaking, there's a control, but it means that 97% of people, if that levee fails, are totally screwed because they don't have insurance. So you have to also be taking into account metrics that are assuming, again, controls will fail. Static indicators, again, so this is actually a picture of when I was up in Port Douglas last weekend, so I'm very happy about that. But static indicators like high coral cover or also fish abundance can be poor indicators of coral reef resilience because it's a lagging indicator. It's indicative of favorable conditions in the past rather than what it is in the present. So you can't use static indicators when fundamentally your system is dynamic. You also have to consider that there are what are called pulse type and press type stressors. So I'm going to use less technical terms. So basically you have acute stressors and ongoing stressors. So with coral, ongoing stress like ocean warming, overfishing, makes coral less resilient over time. It's kind of wearing it down over time. So then when there's a cyclone or a coral bleaching event, they're not able to withstand that. So you have to consider the stressors that are occurring over long periods of time that may not have as strong of an impact right now, but are kind of like, again, it's that notion of wearing it down over time. So another metric is how many ongoing stressors exist. It's possible that you have so many ongoing stressors that you are not actually able to withstand some sort of acute event. Then also, how frequent are acute stressors? Maybe you don't have that many ongoing stressors, but acute events are frequent enough that any sort of ongoing stressor will reduce the system's resilience. Another example is financial systems. I think all of you are probably familiar with the financial crisis. People generally accept that that was really bad for the world, and now they want to try to avoid it. So what regulators did is implement things, a few different things, but the Basel capital requirements, which basically says that you have a certain number of risk-weighted assets that you can have in your bank. You have to ensure that you have adequate liquidity in case any of those assets go under or written down. In some ways, you can think of Basel III a little bit like GDPR in the sense that it's very well intentioned, but doesn't really solve the problem that we're facing, and also is pretty open to interpretation. With that said, the reason why, if you look kind of post-2008, a lot of academic research has been focused on financial system resilience is because they don't want to have that sort of like global financial meltdown again. The key question is, in a financial network, at what point does one default, like let's say a Bear Stearns, lead to a cascade? So some of the research has shown that Basically, it can take a very small shock at the right kind of node in the financial network to actually tip everything over and lead to cascading failures. And so the way that people test it is looking at different capital ratios, for example, under Basel, and determining, okay, where in the network leads to that kind of systemic risk and that systemic failure, which is pretty interesting. What they found is that the riskiest nodes are those which have high connectivity and also a large fraction of contagious links. This doesn't actually mean the biggest, so it's not about too big to fail. It could be a smaller bank, maybe a credit union, that is loaning out money, maybe even in smaller amounts, to all of the banks, let's say in the United States. And because they're that central hub, and because they basically they are lending a lot of the time, let's say it's like every day or overnight as it is in financial terms, they need some sort of minimal capital requirements because they're more at risk. Whereas a bigger bank that maybe has more assets and maybe is even making bigger loans, but only to a select number of people, doesn't need the same level of kind of stringent capital requirements. It's about the connectivity and potential for contagion. Another study has shown internet connectivity is generally a good thing for financial systems. That was certainly the thinking leading up to the financial crisis. In a lot of ways, you get benefits from performance and obviously ability to get your money out faster, all sorts of stuff, just general velocity of money. The problem is that only works up to a point. There's actually a threshold of kind of like the size of an acute shock, after which interconnectivity actually starts amplifying whatever the negative shock is, and it starts rippling throughout the financial system. So not all transactions are actually equal, because some are actually creating potential insolvency cascades. So again, even if it's a small bank, if they're kind of creating a risky transaction that is particularly creating that kind of like central hub that could create a lot more contagion or serve to propagate contagion, you have to treat that transaction quite differently than normal transactions. What they propose is something called the systemic risk tax. This is taxing transactions based on their level of systematic risk. So it's looking at network centrality and looking at what the systematic importance is of that singular transaction. This is totally different than the Basel III requirements. All that's looking at is just like total assets in the bank's balance sheet. This is really looking into, okay, let's measure what the potential systematic impact is, which is really digging into the cause of the financial crisis. But I'd like to bring it more home to technology and talk about resilience metrics and DevOps. As I mentioned earlier in the presentation, I really think DevOps and Infosec should be much closer linked because they have a lot of the same common goals. So a very brilliant friend of mine, Dr. Forsgren, has a great quote, which is, "Maturity models are for chumps," and I happen to agree. From the DevOps perspective, it's because DevOps is a direction and not actually a destination. And her point is that technology changes so rapidly, the idea that you can be mature at any point in time when you have all that evolution happening in the background is pretty ridiculous. So basically, whatever your program is in 1 year will be outdated the next year. I think that's definitely true in information security as well. So I think there are mutually exclusive beliefs that I hear a lot of the time. So that is, InfoSec is ever evolving. It's a cat and mouse game. We can't keep up. Attackers keep changing their methods and so forth. But there's also this sense that your security program has this kind of beautiful, idyllic end state. They're incompatible. The book by Dr. Forsgren, Accelerate, which I highly recommend reading, actually performed a very rigorous data analysis of which metrics in DevOps correlate with success. So again, this is like actual really solid data science and trying to empirically measure what metrics and the degree of performance in those metrics contribute to success. What they found is that successful measures tend to have two characteristics in common. First is that they're global. This means organizational level, not team level. This is not about optimizing the performance of your team, but optimizing your performance of the team in the context of your organization. How are you contributing to the organization's overall health? The other characteristic is that it's focused on outcomes versus outputs, which is really important, and I'll get into that distinction in a minute. First is global. Intra-organization teams shouldn't be pitted against each other. I think security a lot of the time, probably somewhat willingly, pits themselves against other teams, but they shouldn't do that. Fundamentally, you are on the same team, you're in the same organization, and you need to be working together. If you don't, you're going to be low performing, empirically speaking. And outcomes. It's about what actually helps your organizations. A lot of things don't, particularly a lot of things in security don't actually help your organization. The way I put it in my keynote is like making a sacrifice to like the elder Infosec gods that have some indefinable or inscrutable motive. So the Harvard Business Review, I think very succinctly puts it that outcomes are the difference made by outputs. Outputs are not adequate in metrics. You can have like tons of metrics around outputs and show that we're doing lots of security, but if you're not actually resulting in some sort of beneficial outcome, it fundamentally doesn't matter. From the research, they found that 3 metrics in particular contributed to high performance and success in DevOps organizations. This was lead time to deployment, release frequency, and mean time to recovery. First is lead time. So you can break this up into 2 parts. So it's time to design a feature and actually plan it out, and then time to deliver a feature to a customer. If you want, you can bundle it together, so it's the time from when you receive the customer request to when it actually gets into their hands. Release frequency. So in the traditional manufacturing model, there's this concept of batch size, which is the amount you produce at any time. And modern manufacturing thinking is that you want smaller batch sizes that are kind of optimized based on demand. That way you're not creating excess inventory. So release frequency is, I guess, the software version, because software is kind of this intangible inventory or invisible inventory. So release frequency means that you're probably releasing kind of smaller batches of code or smaller batches of features of a smaller size and being able to push it out more frequently. And finally, mean time to recovery, or you'll see here MTTR. This is how quickly can service be restored. This probably sounds a little familiar from the security lens, and I'll get into that as well. So this is really accepting that failure is inevitable. Particularly in very high velocity organizations, you're going to have failure. You'll never be able to escape failure. It's just something that's going to happen to you. So measuring something like mean time to failure can actually work against you, because then the incentive is to inhibit change and to maintain stability, which is probably against the organization's goals. The organization wants to release a product, produce a service, whatever else the organization does. It doesn't want to stay the same. And trying to optimize for reducing a failure will probably cause things to stay the same more than pushing the boundaries and trying to grow. Your empirical research also showed that there's actually no trade-off between improving performance versus stability or quality. A lot of times you'll hear kind of out in the ether that there is such a trade-off. This is why being able to empirically measure actually makes a lot of sense. But actually, when people start improving performance, stability and quality went up. So for high performers, the stats they found were that deploy frequency was on demand. For low performers, it was something to the tune of like multiple weeks was how long it took them to deploy, upwards of a month. The lead time to release, for example, like once it gets into the hands of customers, was less than 1 hour. Same with mean time to recovery, it was less than 1 hour, where for low-performing organizations, it could be days or even weeks. But that's not all. It's one thing to focus on the technology, but you also have to consider the people and, again, crucially, the processes. So Westrom has this model of culture, which is that you're either power-oriented, rule-oriented, or mission-oriented. I'm going to delve more into mission-oriented. I think the other 2 are somewhat self-explanatory. But power-oriented, for example, is like trying to keep kind of protecting your own turf, like keeping the power of your internal team rather than looking into the organization. It's a very like territorial. Rule-oriented is that, you know, we have these processes, we can't deviate from them. This is like the way our organization does things. There's no room for context. But mission-oriented, or what's called generative culture, is the one that works better. Some of their characteristics are that there's solid information flow. Information moves very easily and efficiently between teams. That's something I see missing a lot in security. Information just fundamentally doesn't flow. Also, information is actively sought. You aren't working in silos, you're trying to collaborate with teams and get information out of them as well. A key part, though, is that messengers aren't shot. For example, if an engineer discovers some sort of vulnerability, the security team's already like super wiped out, they're burned out. they don't get blamed for the fact that they found it. You have to make sure that people are appreciated for bringing things to your attention. Responsibilities are also shared. There's no such thing as, oh, it's the security team's responsibility or engineering or, it's sales team's fault. No, it's that it's an organization level responsibility. And cross-team collaboration is actually rewarded. That again, you don't get a reward if you did everything in a silo. It's actually better if you're working across teams. Then finally, failures are treated as learning opportunities for improvement. There are no fingers being pointed. There's no trying to sweep it under the rug. It's okay, this failed, how can we learn from it? Let's really dig into the root cause analysis and try to leave any of our biases out of it and figure out how we can improve it for the next time and going forward. Again, that plays into the idea of resilience and improving over time. That's the journey, not the end state. So my question for you, you don't have to answer, obviously, but how many or few of these actually match your Infosec culture? Because I'll say from the lots of practitioners with whom I speak, very few of these actually exist in most security team cultures, and it's something that is a problem. So how do you start measuring Infosec programs, specifically for resilience? I really want to stress this, that your program's goal is not actually maturity, it's organizational level, continuous resilience. It's not just the security program. You have to be thinking about your organization as the customer. If you aren't helping your organization, you're not really doing your job. You're hired to do that, not to pursue some sort of noble goal in security. You have to aim for resilience-led outcomes, not outputs of security dogma. It would be easy enough to implement very stringent, very, no man, saying no to absolutely everything requirements that may make you feel good from a security perspective, again, being a security zealot and really adhering to those quote unquote immutable principles about what a good security program is. That's not actually going to benefit you, and those metrics won't help you work towards a goal. You have to aim for resilience-led outcomes. So again, back to the robustness, adaptability, and transformability. So I somewhat vainly, in my prior presentation on resilience, attempted a definition, since people were talking a lot about Infosec resilience and not really defining it, that in Infosec, resilience means a flexible system that can absorb an attack and then reorganize around the threat. So what are the metrics for each of those components? For flexibility, can your program serve your organization's needs in the way it needs? You can probably meet their needs in a way that doesn't actually work and it's going to slow them down, but that's not effective. Again, you have to consider global results. Zealots, as I call them, the security zealots, combating the quote-unquote unenlightened, that just don't care enough about security and don't take everything, super mission critically, is really unhealthy. You have to be viewing them as partners and, again, think about that cross-team collaboration. The other thing is prioritizing Infosec versus org-level goals can lead to inhibition of innovation. Obviously, this isn't true all the time. Sometimes innovation is bad. I would argue, for example, the ubiquity of facial recognition systems would be a very bad thing. Maybe you should raise privacy concerns. I'm not saying that. I'm saying in general, though, you need to try to work with other teams and work into their workflows, because if they don't want to use it, it won't help you very much at all. So I propose you need to measure impact both ways. You have to measure improved security, but then also looking to see if you're creating a tighter bottleneck. So positive impact. Reduction in the number of security fixes per release. Wouldn't that be great? You're making a positive impact in security. But it's negative if you're increasing engineering time spent on using the security tools. If you're adding a few days to the release, they are no longer a high-performing DevOps organization. But what's interesting is that the book, which is DevOps themed, again, not security themed, found that high-performing DevOps organizations spend 50% less time remediating security issues. So that's also something to keep in mind, is if you just help enable the engineers to do their job better and to DevOps better and have that high performance, you're probably going to be building in security better in the first place. So some metrics to track that would be mean time for security reviews. How long are your security reviews taking? You can also look at how many times are security reviews being conducted, which could actually be a good thing if there are multiple touch points in the life cycle. look at how early in the process those security reviews are happening. It should be included in the design phase with product managers, but I think most of the time it's not. It's that just-in-time pre-GA security review. Then also the mean time for threat modeling. These are exercises that can take a really long time, and ideally you want to get the engineers in the habit of thinking through some of these problems early and trying to streamline that process so you're not having to really dig out information from them all the time. For absorbing an attack, this is about reducing contagion and adapting efficiently. So first, where are your highly connected and highly contagious nodes? Remember the example in financial systems. These are the ones, even if they're small, that could pose the greatest systemic risk to your organization. So you can borrow a metric from finance, which is the amplification ratio. So measure it on an ongoing basis. What does the PON of node 1 or whatever it could be an endpoint, it could be a system, it could be a product, a feature, it leads to what amount of total damage. You need to be viewing it in that systemic context rather than just, okay, this is something that's publicly facing, blah, blah, blah. Like really look at how highly connected it is. Also track ongoing stressors like complexity as well as employee turnover. I think people underestimate how much employee retention can hurt security programs. But then specifically for complexity, it becomes very prohibitive to start testing every app in every system if you have a lot of complexity because there are a lot more paths to compromise. So that's, again, the idea of that wears down resilience over time. So you have to be able to understand what the impact of an acute stressor would be. For example, a new vulnerability or a new breach. How much are those ongoing stressors affecting your ability to actually respond or recover? So metric there is a new MTTR, very similar to recovery, but mean time to remediation. How quickly do you resolve an incident? Importantly, here you have to think about transformability, which is the next bit, but you need to make sure that you are preparing your organization to respond effectively. And again, that's very tightly linked with DevOps. They want to recover quickly as well. Again, mean time to failure, for example, an incident, can prioritize unhealthy stagnation. Yeah, you could probably air gap every single system and you avoid failure, you avoid an incident, congratulations, but your organization can't do anything now, so that's not a good metric to optimize. You can also look at deploy frequency of configuration management. That also plays into adaptability. How quickly can you put out firewall rules or patches? I think we all heard about Equifax. The fact that they weren't able to patch quickly, and I'll get to them in a second, is part of a lack of adaptability. Then finally, how do you reorganize around the threat? Can you transform and can you innovate? Think about the systemic risk task for tech. Can you incentivize resiliency by throttling cascade creating nodes? So can you view or figure out which system or which nodes are creating that kind of central risk that affects the rest of your organization, and hopefully incentivize engineers to either not design systems that way or stop using those so much and try to spread around the risk. As in both finance and DevOps, there's actually no such thing as a single optimal architecture. A lot of it is contextual based on your organization. So what they found in DevOps is that the type of architecture, other than mainframe systems that tend to perform poorly, what actually matters is the characteristics of the architecture, which generally is about independence. Can you push changes without having to check across a bunch of other different teams? Same with financial systems. It really depends on context, which one is going to do better. So you need to measure the levels of interconnectivity, centrality, and correlation of IT systems. Those will help you identify your systemic risk much better. So one cute little formula I came up with is looking at acute stress times the level of interconnectivity is the potential propagation of PON, trying to really figure out what the potential contagion risk is for a particular node. Also think about how is your security's time being used. For example, I did a very, very informal survey online about the average amount of time spent on maintenance for different security products. Team maintenance was in the absolute max bucket, which was 35 plus. Let's say it's 30 hours per month. That's 12.5% of work time. Let's say they're making $100,000. So that's $1,000 or more per month that you're spending on maintenance. The problem is that time usage can be generally placed into three distinct buckets, which is problem solving or security innovation, firefighting, which I think we're all familiar with that, and then meetings and maintenance, kind of the repetitive stuff we don't really want to do. This is borrowed from the Accelerate book, but roughly a good organization would spend 50% of their time on security innovation. So really thinking about how to push the boundaries of like the architecture, underlying systems, even creating their own scripting or tooling in order to improve security, and again, meet that vision and those goals that are about resilience. 30% would be on repetition. Obviously, it's better to automate those tasks. And then 20% on firefighting. A bad organization is much more equal. You can see here that even that difference of 15% in security innovation means you're a lot less likely to reach your vision and those goals of resiliency. You simply won't have the time to work towards those. You also need to consider how strong is your culture. As I mentioned before, Infosec culture is not particularly great. It tends to be more rule-based or power-based. So are you actually mission-oriented? Great example is Equifax blamed one person, the CEO blamed one person for failing to deploy a patch as to why they had that catastrophic breach. I think all of us in here know that it's not actually that one person's fault. It's like a bunch of different factors that were involved. So don't do that. That's an example of a power-driven organization. In a complex system, it's never actually one person or variable. You cannot point the finger at just one person. You have to view it in context. So one thing that I always like to remind my Infosec friends is that if a user clicks on a link or if an engineering team doesn't include you early in the design cycle, in some ways that's a failure of your security program. So don't blame the user, don't blame the devs. Like, if they're not securitying well, there's something wrong with your program. That's also your responsibility. Again, responsibilities need to be shared. You need to get to the root cause, not point fingers, and figure out how to improve your program so it doesn't happen again. A quote that I really like, again from the DevOps side, is when the tools provided actually make life easier for the engineers who use them, they will adopt them of their own free will. That's a really important point. A lot of times security technologies are totally unusable, particularly anything in the like vuln management or application security testing space. Engineers have a really hard time using them, so they're not going to. Some of the metrics you can track are just the percentage of your teams using AppSec testing, the percentage of 2FA usage across departments. Probably your engineering department is pretty good with two-factor, maybe the sales department not so much because they need to log in really quickly. Then you can also look at the number of security support tickets filed. That's a really good indicator of how well you're doing. I see I have 1 minute left, so I'm going to breeze through these. Net Promoter Score, you may be familiar. It's basically a mathematical calculation of satisfaction. So measure NPS among your colleagues and teams with whom you work. So it's kind of funny, but how likely are you to recommend our security program to a friend? You can deviate that from that script a little bit, but fundamentally, if your org doesn't believe in you, you will be alone in the quest for resilience, and you don't want that. It has to be a team effort, and you have to be measuring whether the rest of the organization feels like you're empowering them. Finally, a note on diversity. It enhances adversarial analysis, true red teaming. I have down there, I highly recommend Toby Kohlenberg's talk. Red teaming probably isn't for you because you really have to play devil's advocate, and diversity helps with that a lot. Final note, there is short-term pain. This is not easy. Progress will follow a J-curve, but it is worth it in the long run. So in conclusion, measuring security is easier than you believe. Don't wait for the magical fairy. You have to not consider it crusade, however, otherwise you'll never actually be able to measure it. You have to care about outcomes, not outputs, and embrace the continual process. You also want to measure resilience, flexibility, adaptability, and transformability. And measure how your security is helping, your organization, not security dogma, not that abstract concept of security morals. You also have to measure more than just technology and tools. You have to consider people and culture as well, because they will help you towards resilience. Then, consider DevOps your new BFF. They're not actually frenemies. You have to work towards your common goals, because as you've seen with a lot of these metrics, there are actually a lot in common. Finally, to close, have no fear of perfection. You'll never reach it. Again, it's a continuous process. Do the best you can, make sure to track it, and you're a lot more likely to paint your vision than you thought before. So with that, thank you very much.
Did anyone have any quick questions?
I think it's lunch, so I'm happy to answer questions.
All right, we'll break for lunch and we'll all be back at 1:20 when we can go for the next round.